As we're taking a look at 8.2, we're going to be doing law of signs, and this is specifically the ambiguous case. When we're looking at the ambiguous case, that only happens when you're dealing with this one, where it's side, side, and then the angle not included. So the angle that's not between the two given sides. So that's where we have to watch out, because sometimes we could have two triangles. Okay. And to give you guys a visual, you guys can take a look at, if you guys look at our Canvas page, I put a little picture there. And then if people in class can see this guy here, let me. It's not switching over. There we go. So you guys can visualize it in class here. So sometimes you might have where a triangle, that side, 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 this side right here could be swung out and create two triangles when we have side, side angle. Okay. So here's the given side, and then the red one, A, is also the given side, and we could create two different triangles. We could create an obtuse triangle or an acute triangle. So it kind of depends. We have to be very careful when we do this. Okay. So as we take a look, make sure this is going here. So as we take a look, you can follow these rules in terms of the height, what we have. So if you look at all these guys, there's restrictions on the height, and that will determine if you have different triangles. Or what I like to do is I like to look at the angles. Okay, so you can follow these rules if you want. I usually don't. I show you kind of the easy way to do it. Okay, or you can follow these rules where height is h times the sine of alpha. Okay, so let's put this in action. When you start seeing it, it's like, it's not so bad. They'll start making sense to you. So let's go ahead and get started. So here we go. Example 1, I've got side, side angle. And anytime we have two sides in the non-included angle, we go, this one could be a real pain in the SSA. So we have to check for two triangles if we're using our law of signs here. So watch out. So we got to check for two triangles. So law of signs, we take and use the given angle that we have. We have the sine of 30. So the sine of 30 over what? What's across from 30, y'all? 5? Perfect. Now the other side that they gave me was 3. And 3 is across from what angle? What do you got? Andrew, what do you got? That little fancy y, we call that gamma. All right, so we're going to solve for gamma first. And we said yesterday, if you're looking for an angle, just multiply both sides by that denominator, so those guys cancel. And now we got 3 sine of 30 over 5. And now that's equal to the sine of gamma. Well, if I want to find the angle gamma, what do you have to do to both sides? Ains, what can we do to both sides? Yeah, how do we get the gamma by itself? How do we get rid of this sign? It's like dividing it over, which is doing what we call the inverse sign. So we're going to inverse sine both sides. It's kind of like if you take x times its inverse, they cancel out. Same thing here. These guys kind of just cancel out. And then we get gamma is equal to the inverse sine of 3 sine of 30 over 5. This is where you can plug it in, plug it in. So take your fancy calculator. I got inverse sine, and then I've got 3 sine of 30. And on the bottom, I've got 5. Okay, so I end up with 17.45. I'm going to go ahead and round to 17.5. Is that what you guys got? When you plug it in, double check. Make sure you're, especially if you have a TI-83, Sometimes you guys don't have that fancy fraction. So make sure you got what I got. Y'all good? Good? They may need a calculator. Y'all good? All right. Well, this is where I put a little slash here, and now I've got to check for two triangles. Okay. The idea is when you did inverse sine back in the day, we worked from pi over 2 to negative pi over 2 or 90 to negative 90, right? So when you do inverse sine, you could get something in quadrant 1, which is what we got, 17 and a half, or you could get something in quadrant number 4, which would be negative 17 and a half. Well, that is not in the correct quadrant. If we're talking about a triangle, you can't have a negative angle. So what we have to do is put that in quadrant 2. And to do that, we take 180 and add it to negative 17 and a half, or basically subtract it from 180. That's going to give us that obtuse angle that we need to check. So we're going to take, if I want gamma 2, that's subscript, so I can tell them apart. I'm going to take 180 minus the angle that I just came up with, and then I'm going to see what I get. I plug it in, what do you guys get? What's 180 minus 17 and a half? What do you guys get? There we go. We got 162.5. Okay. So for me to check now to see if it makes sense, I take 162.5 and I add it to the given angle, which was 30. And then I compare it to 180. Which one's bigger? 162.5 plus 30 or 180? This is 190, right? 192.5. Can you have a triangle more than 180 for a total angle measurement? No. So this guy is way more than 180. That means there's no room for that third angle, which means there's only one triangle. Okay. So because these two angles add up to more than 180, there's not enough room for another angle. That means this is impossible. That means I got to go back over here and find that one remaining triangle. There's only one, so not two. Does that make sense? You guys good with that? All right. So here we go. I got my beta is 30. I got gamma, and now I can find alpha. Alpha is just what's left from 180 when I subtract gamma and beta, which is 30. So go ahead and do that computation here. I got 180 minus 30 minus 17 and a half. And I got alpha is 132 and a half degrees. All right. Am I done? Oh, I'm not done. I'm missing what? I'm missing the side, so I got to find little a. All right, so that's where I bust out the old law of sines again. So I always like this guy right here that I started with, so I'll use that, the sine of 30 over 5. I still need to find the missing side, which is a, and across from a is alpha, what we just found, which is 132 and a half. All right, when I'm finding that side, we talked about cross multiplying. And I got a times the sine of 30 equals 5 times the sine of 132 and a half. And then we divide over. And then we plug it in. Take this guy, plug it in, and see what you get. The worksheet says round to the nearest tenth, so we're just going to round again to 1 decimal place. So use your little fraction. I got 5 sine of 132 and a half. And on the bottom, I've got the sine of 30. So if I round, that's about 7.4. Okay. Questions with that one? So this is an example where you just get one triangle, even though it's angle side side. Y'all good? All right. Let's take a look at one where you do get two triangles. Now, if you want to draw this guy out, you can. Just, this is, again, not drawn to scale. I got B as 8. I got C as 10. And then beta is across from that, which is 45 degrees. Well, I got to find gamma. I got to find alpha. And I got to find little a. And again, this is an example of side-side angle. And anytime you guys have side-side angle, you've got to check for two triangles. All right. So here we go. We dive right in. The given angle I got is 45. Across from 45 is 8. The side that they gave me was C, right, which is 10. And then that allows me to find the angle, gamma again. So far, so good. All right, let's find gamma. Multiply both sides by 10, so these guys cancel. I get 10 sine of 45 all over 8, and that equals the sine of gamma. And then Ainsley, what do we got to do to both sides?
Inverse sine.
There we go. Go ahead and inverse sine that. Boom. And this gives me gamma. All right, so inverse sine. Here's my little fraction. I got 10. I got sine of 45, and that's all over 8. And there we go. I got about 62.1. Well, now I've got to check for two triangles. I got to see if there's another angle that will create another triangle with this information. All right. So can I extend out one of these sides and make it bigger? Okay. So how do I do that? Well, let's see if gamma 2 works. Gamma 2 would be 180 minus gamma 1. So again, gamma 2 would be 180 minus that angle I just found, 62.1. All right, so I take 180 minus 62.1. That will give me its supplement, 117.9 degrees. Then I compare. I look at the angle that was given, 45 degrees, and I look at 117.9, and I say, is there enough room? Which one's bigger? Is 180 bigger or is 117.9 plus 45 bigger? Which one's bigger? The 180 is bigger, right? So this guy's bigger. Well, that means there's enough room for a third angle, which means we have two triangles. Exclamation point. So because 180 is greater, that's why we have two triangles. So that means we got to find that third angle, alpha 2 here. We take 180 and we subtract gamma 2 and we subtract that beta. All right, so we take 180 minus 117.9 and we subtract 45, and that gives me alpha 2, which is 17.1 degrees. And then last but not least, we got to find that side that's across from that angle. So that's where we go back and we use our law of sines, I always go back with the first one I had, the sine of 45 over 8. We got to find little a sub 2. And across from little a sub 2 is alpha sub 2. So I got the sine of 17.1. Again, we do a little cross multiplying. Again, I don't need to see this work, guys. I think you guys can do this in your head. I would multiply both sides here, 8, and then sine of 17.1. And then I would divide this guy over, so the sine of 45 is divided. And then I can just throw that in the calc. Start fresh here. I've got 8 sine of 17.1. On the bottom, I've got the sine of 45. So a sub 2, the little side across from alpha sub 2 would be 3.3. Okay. And that's all the information from the second triangle. Am I done? I'm not done? Oh. So I found all of the information from that second triangle. Now I got to go back and find all the information from the first triangle. So this is gamma 1, and I got beta is 45. Well, now I can find alpha sub 1. So I can go back and use 180. I'm going to subtract 62.1, and I'm going to subtract 45. So again, I take 180 minus 62.1, and I'm going to subtract 45. Now I got 17.9 degrees. Anything else I'm missing? What else do you need? Sal, what's the last thing we need? I got to find that side again. I got to find that little a sub 1 again. So I've got the sine of 45 over 8. And now I want to find little a again. Little a is across from alpha sub 1, which is 72.9. When we're finding that side, it's just cross multiply. If you want to jump right to this, 8 sine of 72.9, and you're going to divide over the sine of 45. And let's plug it in, plug it in. The nice thing about law of sines is you've used that before, and if your calculator allows you to go up there and just change those guys, it makes it nice and easy. So we have 72.9 in there now. And that gives me my value 10.8. So they gave us 3 things in the triangle. In this case, they gave us side-side angle, and those can be a real pain in the side-side angle, the SSA. Because sometimes there's 2 triangles. Sometimes this is like double the work. So it's a pain in the SSA sometimes. Okay? And sometimes, on example 3, it's not. Because sometimes they give you 2 sides in that non-included angle, and sometimes this doesn't make sense. Look at the information they gave you. Why does this not make sense? If you look at example 3, why does this not make sense? Any ideas? They gave you A is 2, they gave you C is 1, and then the angle across from C is a hundo. Why does that not make sense? Kate, what do you think? Right. So gamma's the big guy, right? Gamma's the largest angle, and across from the largest angle has to be the largest side. But that's not what they have here. Okay, so this is going to be a no solution. right? Abby, is that what you're going to say? Pretty much. Okay. Across from the largest angle, so you can see it, across from the largest angle is the largest side. If that's not the case off the given information, then you can't make that triangle. It's impossible. Okay? If I set up law of sines, the angle I have is 100, and across from gamma is C, which is 1. And then I did, okay, the side I got is 2, and across from A is alpha. So then if I'm solving here, I'd multiply by 2. And those guys would cancel. And I got 2 sine of a hundo equals the sine of alpha. And then if we do it, Ainsley said, inverse sine both sides. And then this would cancel. And I plug this in. We're going to do an inverse sine of 2 sine of a hundo. And then I get a domainer. 2 sine of 100 is pretty big, right? It's more than 1. And you can't have anything more than 1 inside an inverse sine. Okay? So, no solution. Can't do it. Can't do it. Wish you could, but you can't. All right, so again, no solution on that. If you see that right away, can't do it. All right. You guys have any questions with side angle? Do you see why it can be a pain in the side angle? Oh, man. Now, homework tonight should be not too bad. But know what you're doing. Okay? As I'm looking at examples 1, 2, 3, and 4, look at what they gave you. In example number 1, this is an example of angle, and side, where the side is not between the two angles. This is angle, side. You do not need to worry about an ambiguous case. There's no need to. Kind of same thing with this one. This is angle, side, angle, where they gave you the side in between the two given angles. There's only one triangle you can make with those. You don't have to worry about the ambiguous case. Anytime they give you two angles, you don't have to worry about an ambiguous case. But when you get to 5, 6, and 7, where they give you one angle and two sides, then we got to start worrying about that ambiguous case. Okay, so be very careful. And I went through 3 examples today, and guess what? I gave you 3 questions on homework. So you can assume one's going to work, one's going to give you 2 triangles, and one's going to give you nada, nothing. And you can probably find the one that's going to give you nada, nothing, no solution. Which one's the no solution off the bat? Can you see? Yeah, number 6, right? B is 95. 95's got to be the biggest angle. Well, over here, B is the small side. So right away, I know this guy's no solution. Across from the biggest angle is the biggest side. And if that's not the case, you can't make a triangle like that. All right, ladies and gentlemen, that is it for law of sines. Law of sines is over. You guys have any questions? Questions?